In this video, we want to look at the concept of position and displacement and all of the various ideas that go along with understanding how we find position and what the difference is between distance and displacement. Position is defined as the location of an object. In physics, we'll typically specify this with graphical coordinates. So if we're dealing with the x-axis, for example, we set the origin as our 0 point, and then we tell how far away from the 0 point the position of an object is located. The variable that we use for position, which you learned in your units and variables video, is x, and we're generally going to use a position with meters as the units. We will generally set the origin as 0. That's not required, but that's generally what we're going to do to make things as easy as possible. One of the things that you're going to see in physics that's a little different from math classes and a little different from things you may have seen before is that we have to specify direction. Anytime we're solving a problem that's in one dimension, we are generally going to specify direction as positive and negative. So if we have things moving left and right, we'll make one direction positive, the opposite direction negative. Or if we have things moving up and down, we'll make one direction positive, one direction negative. It does not matter which way you choose to make positive and which way you choose to make negative. It makes absolutely no difference as long as you are consistent within a given problem. You can change it the next time you do a problem to do something that makes more sense to you in the next problem. But each time you must specify which way is positive and which way is negative. And you must understand in physics that when you have a positive or negative value, it doesn't mean greater than 0 or less than 0. It just means opposite directions. So if you see positive 5 as one position and negative 5 as the other position, it just means they're in opposite directions. So for example, if I were to draw an axis here and I said this is my 0, and I have a scale 1, 2, 3, 4, 5, I have a scale 1, 2, 3, 4, 5. I've got one object at this point, and one object at this point. I would say that the square has a position I'm going to make to the right positive. It does not matter. You could make to the right positive or negative. If I make it positive, I'm going to say that the square has a position of positive 4 meters. And I'm going to say the triangle has a position of negative 3 meters. So to the right is positive in this case, and to the left is negative. Someone else could make to the left positive and to the right negative. So they would get negative 4 for the square and positive 3 for the triangle. It doesn't matter which one you choose to do as long as you're consistent throughout the problem. And understand that positives and negatives mean opposite directions in this course. Now, when we talk about position, we generally are more interested in talking about the distance or displacement that something travels, the actual movement of an object. Just an object sitting still in place isn't very interesting to study, but an object that's moving has a lot more interest to us and is a lot more applicable to real-world cases. There's a big difference between distance and displacement. Distance was our variable d that we talked about the other day. It's going to be in meters. Distance is the interval between two locations is one simple definition. A very precise definition would be the scalar measure of the interval between two locations measured along the actual path connecting them. So if you were to walk, say we had a person, and they walk 5 meters to the right, and then they turn around and walk 4 meters to the left, they would travel a total distance of 9 meters. So they walked 5 meters, then they walked a distance of 4 meters for a total of 9 meters traveled. The difference becomes when we start talking about displacement. Displacement, if you'll remember, is our variable delta x. It's also going to be in the unit of meters. But this is what we refer to as a vector. A vector is something that includes direction. So this is the distance and direction of the shortest path between the initial and final position. So we go back to that same example we had before. Someone walks 5 meters to the right and then 4 meters to the left. Their original position was 0. Their final position is plus 1 if I'm making to the right positive. So the displacement here would be 1 meter positive or to the right. So it's just the distance and direction from the initial position to the final position, irregardless of the path that they traveled. So they walked a distance of 9 meters, but their displacement is only 1 meter.